All right, so I quickly want to define a few things that we're going to use in class on Monday. And the first thing is what's called the transpose of a matrix A. And this is denoted A with the superscript T for transpose. And it's the matrix formed it's the matrix whose columns are formed by the corresponding rows of A. So for example, if A is equal to the matrix, let's say 4, 0, 5, 3, 6, -1, then AT is equal to the following. So here we see that AT is a matrix whose columns are formed by the corresponding rows of A. So the first column of AT is going to be equal to the first row of A. So here I'll have 4, 0, 5. And similarly, my second column of A transpose will be equal to the second column, the second row of A. So I'll have 3, 6, -1. And one thing to notice then, A is a 2 by 3 matrix, and the transpose of A is a 3 by 2. So notice we're switching. So here I have 2 rows and 3 columns. And here I've got 3 rows and 2 columns. Okay, and the next thing that I want to define with a matrix is the identity matrix, but let me define a couple of things to get there. So first, the diagonal entries of a matrix let's say A, and I'm going to let A be represented by this, where entry Aij is the entry in the ith row and jth column. So the diagonals are the entries, and I'll say A11, A22, A33, up to however big your matrix is. And I think this is easier to see on a picture. So here, if this is my matrix, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, then the entries on the diagonal are just, here's entry A11, A22, A33. So it's the things on what's called the main diagonal. Okay, and we say that a diagonal matrix is a square matrix, meaning it has the same number of rows and columns. So we'll say with dimensions n by n. And so diagonal matrix is a square matrix with dimensions n by n, whose non-diagonal entries are 0. And by non-diagonal entry, I just mean something that's not on the diagonal. So in this above matrix, it would be the parts circled in blue. And so the matrix above is not a diagonal matrix because it has entries that are non-zero above, or sorry, non-zero on the, that are not on the main diagonal. And okay. But an example of this would be the following. So here I have, I'll do n equals 3, and I could have 1, 0, 0, 0, 4, 0, 0, 0, 6. And so here I see all of the things in the on the non-main diagonal, or non-diagonal entries are 0. And so that tells me this is a diagonal matrix. And so one question, what about the following? So let's say I have 2, 0, 0, 3, 0, 0, and oops, sorry, 1, 0, and then 0, 0, 7. And so my question is this a diagonal matrix? And the issue, or the area of possible concern, is this 0 right here that's on the main diagonal. But we see this definition has nothing to do with the main diagonal. So entries on the main diagonal can in fact be anything, including 0. What we're looking for again are these non-diagonal entries. And here both of these, or all of these, are 0. So that's fine. So this is in fact an example also. And okay, but there's a special type of diagonal matrix, and that's a matrix called the identity matrix, which you may have seen before if you've done anything with matrices before. And this is denoted IN, and this is a n by n diagonal matrix whose entries on the main diagonal are 1. And so for example, I have that I4 is a 4 by 4 matrix where the entries on the main diagonal are all going to be 1. Okay, and so this matrix right here, this identity matrix, is a special matrix, and we'll use that one a lot. Okay.